Hello, my name is Troy Stopera, and my senior design project is a computer science education tool called GenCode. Before I get into what it can do and how it works, I'd like to first talk about why computer science is so important. As everyone knows, computers are playing an ever-increasing role in our day-to-day lives and can be found in your cars and even your pockets. Not surprisingly, this has led to an increase in the demand for computer science professionals. In fact, 71% of new STEM jobs are in computing. However, only 8% of STEM graduates graduate with a degree in computer science. This might have something to do with the common perception that computer science is hard, or so hard, or even boring. But that's where GenCode comes in. GenCode is computer science education at your fingertips. There are three important parts to GenCode that I would like to discuss before moving into a demo of what GenCode can do. The first of these parts is the instructor settings. From a simple web interface, instructors can log in and create a lesson with just 5 simple inputs: a lesson title, a problem topic, difficulty, question count, and description. From here, the instructor's preferences are sent to a generation algorithm which generates code and questions to go along with the code, which are then directly sent to a student's phone. That brings me to my second point: students' performance. Once a student receives a lesson on their smartphone, they are free to complete it as many times as they would like. Each answer given by a student is uploaded to a back-end server where instructors can monitor performance. They can monitor performance on an individual level or for the class as a whole. From here, they can get a good idea of where individual students or the class as a whole is struggling. If an instructor notices that their class is struggling with concepts that they should have learned in a previous course, the instructor can then adapt their course to catch students up to where they need to be. This brings me to the third and final part of GenCode: spaced repetition. Rather than move linearly from one topic to the next, spaced repetition allows GenCode to build a strong comprehension of computer science fundamentals. As students move from one lesson to the next, ideas and questions from previous lessons will periodically show up in the new lessons to ensure that the students remember the topics that they have already learned and been tested on. Furthermore, GenCode can automatically detect which topics individual students struggle with and can tailor specialized questions to help those students keep up with the rest of the class. GenCode is not yet fully functional on a mobile device, so for this demo, I'd like to simply show you some code that GenCode has generated. Here, you can see a simple conditional question with a difficulty of 10. As the difficulty goes up, you can see that the code gets more complicated. With a maximum difficulty of 100, you can see that the code is quite complex and intricate. It should also be noted that no matter how many times the screen is refreshed, a new question is generated. You will never see the same question twice with GenCode. Although this brief demo only displayed conditional-based questions, GenCode can in fact be used to test any computer science topic. Now that you've seen the code and questions that GenCode can generate, I'd like to discuss how GenCode goes about generating code. For this project, I created a family of classes that can be used to represent generated code in memory. They vary from basic representations of variables and values, all the way up to components such as for loops and if statements. Using these classes like building blocks, GenCode is able to create a wide variety of code samples. Using this building block-like architecture, GenCode is able to represent complex code in memory easily. Take, for example, the code on the right side of the screen. When GenCode generates a function like this, what it's really doing is stringing together a series of executable objects. In the end, GenCode is left with a data structure similar to what is seen on the left side of the screen. In this case, there is a function, main, that should execute, and within that, there's a declaration, int a equals 53, that is followed by a conditional with 4 branches, each of which has its own return statement. This data structure is crucial to GenCode's generation algorithm. In the end, GenCode must know what its generated code will return. Rather than keep track of this during generation, which could be complicated and make the generation algorithm take longer to run, GenCode can instead use this data structure to virtually execute the code at runtime and determine dynamically what the program would return. After implementing this virtual execution algorithm, I realized that it could be taken one step further. Instead of just executing the code to determine what it should return, Purposeful mistakes can be introduced into the execution to generate plausible wrong answers for the student's multiple choice questions. For instance, if a student struggles with conditionals, they may know that A, in this case, does not equal 15. They may know that A is not greater than or equal to 62. But they may not know if A is less than or equal to itself. So, if they don't know that, they may very well choose the else option and say that the code would return 30. By introducing similar mistakes into the virtual execution, the multiple choice questions generated by GenCode can be more helpful to a student than one with random wrong answers generated. Furthermore, if a student, in this case, would choose 30, it would be safe to assume that they struggle with the less than or equal to operator. GenCode can then automatically create new questions to reinforce the student's understanding of the less than or equal to operator automatically without any input from the instructor. Using this approach of dynamic education and code generation, it's my hope that computer science will no longer be seen as something that is hard, but rather something that anybody can do.